Welcome back to Learn Math by Example at Sam's Hub. Imagine you're Coastguard, perched at top of a vertical cliff 100 meters high. You spot a ship on the horizon, sailing directly towards you. You measure the angle of depression to the ship and find it's 25 degrees. A few moments later, you measure again. The ship is closer, and the angle of depression is now 40 degrees. Your mission is to figure out exactly how far that ship has traveled. To solve this, we'll need to master the use of trigonometry in right angle triangles. In this lesson, we will define angles of elevation and depression, work through two typical IB style problems, cover some crucial notes for your exams, and finally, we will return to solve our coastal mystery. So let's begin. Before we can solve any problems, we need to be crystal clear on our definitions. It all starts with the horizontal line of sight. Imagine a perfectly flat, level line extending from your eyes. Now, if you look up at an object, like a bird in the sky, the angle formed between the horizontal line and your line of sight is called the angle of elevation. You are elevating your gaze. Conversely, if you look down at an object, like a boat on the water, the angle between the same horizontal line and our new line of sight is the angle of depression. You are depressing your gaze. The most common mistake students make is putting the angle in the wrong place. Always start by drawing your horizontal line. A crucial geometric fact to remember is that the horizontal line of sight is parallel to the ground. The angle of depression from an observer is equal to the angle of elevation from the object being observed. Now, these are alternate interior angles. Let's apply these ideas to a typical IB problem. We need to build a wheelchair ramp. The door is 1.35 meters above the ground. And for safety, the angle of the ramp must be less than 8 degrees. First, in part A, we have to draw a figure. This is always our first step. Now we form a right angle triangle and the vertical height AC is 1.35 meters. The ramp itself is the hypotenuse BC. The angle the ramp makes with the ground, angle ABC, is our angle of elevation. For part B, we need to find the length of the ramp, BC. If the angle is exactly 8 degrees, let's think SOHCAHTOA. Now we know the side opposite to the angle, which is 1.35. And we want to find the hypotenuse BC. Opposite and hypotenuse means we're going to use sine. So, sine of 8 degrees is equal to 1.35 divided by BC. Rearranging this, we get BC is equal to 1.35 divided by sine of 8 degrees. Plugging this into our calculator, we get approximately 9.704. So the ramp length is 9.70 meters to 3 significant figures. Finally, for part C, we need to find the horizontal distance AB. This is the side adjacent to our 8 degrees angle. We still know the opposite side. Adjacent and opposite means we're going to use tangent. Now the tangent of 8 degrees is equal to 1.35 divided by AB. Again, rearranging this, we get AB equal to 1.35 divided by the tangent of 8 degrees. This gives us 9.604, etc. The question asks for one decimal place, so our final answer is 9.6 meters. Now, for a more complex multi-step problem, Tom is in his studio, 6.50 meters above the ground. He looks at a building across the street. The angle of elevation to the top is 55 degrees, and the angle of depression to the base is 18 degrees. Our goal is to find the total height of that building. Now, the key here is to draw a diagram and see that we have two right-angled triangles. They are stacked on top of each other and they share a common side. The horizontal distance across the street, let's call this distance x. First, let's use the bottom triangle, the one formed by the angle of depression. The angle is 18 degrees, and the side opposite to it is the height of Tom's window, which is 6.50 meters. Using TOA, the tangent of 18 degrees equal to 6.50 divided by x. Now, solving for x, we need to find the horizontal distance. So, the horizontal distance is about 25.05 meters. Solving for x, we find the horizontal distance is about 20.005 meters, but it's crucial to keep the full value in your calculator for the next step. Now, remember, never round intermediate values that you will use later for a final answer. Most of the time, this will give you an inaccurate final answer and you will lose A1 mark or marks. Now, we use the horizontal distance in the top triangle. Here, the angle of elevation is 55 degrees. We want to find the vertical height of the top section. Let's call it y. Again, using TOA, the tangent of 55 degrees is equal to y divided by our horizontal distance x. So y equals to 20.005, actually here we use the full number, times the tangent of 55 degrees. This gives us a height of about 28.571 meters for the top part. So the total height of the building is simply the bottom part plus the top part. That's 6.50 meters plus 28.571 meters. This gives us a total of 35.071 meters. Rounding this to two decimal places, as requested in the question, the height of the building is 35.07 meters. Before we solve our main challenge, let's review some critical points. First, always draw a diagram and correctly place the angles. The most frequent error is misplacing the angle of depression. Remember, it is always measured from the horizontal line downward. Second, you are not expected to memorize formulas. SOHCAHTOA relationships are in the formula booklet under topic 3, geometry and trigonometry. Know where to find it and how to use it. Third, check your calculator mode. For geometry problems, we always work with degrees. Make sure your calculator is in degrees, not in radians, or all your answers will be incorrect. And finally, read the question carefully. For rounding instructions, IB exams are strict about this. Giving an answer to the wrong precision can cost you marks. Alright, now it's time to solve our coastal mission. The cliff is 100 meters high. The ship is first observed at an angle of depression of 25 degrees and later at 40 degrees. Let's break this down. Now, we have two right-angled triangles. First, consider the ship at its initial farther position. The angle of depression is 25 degrees, which means the angle of elevation from the ship up to the Coastguard is also 25 degrees. The opposite side is the cliff's height 100 meters. We need to find the adjacent side, the horizontal distance from the cliff. Using tangent, tan of 25 degrees is equal to 100 divided by the distance. This gives us a distance of about 214.45 meters. Now, for the second observation, the ship is closer now. So the angle of depression is now 40 degrees. So the angle of elevation for this new position is also 40 degrees. The height is still 100 meters. So tan of 40 degrees is 100 divided by the new shorter distance. This gives us a distance of about 119.17 meters. Now, the distance the ship actually traveled is simply the difference between its starting distance and its finishing distance. So we subtract 214.45 minus 119.17, which equals to 95.27. Rounding this answer to three significant figures, the ship traveled 95.3 meters. Mission accomplished. So there you have it, the power of trigonometry to solve real-world problems. Today, we defined angles of elevation and depression. Stressing the importance of horizontal line, we saw how to draw diagrams, apply SOHCAHTOA, and tackle complex multi-step problems by breaking them down into simpler right-angled triangles. If you have any questions or want to discuss a problem, share your thoughts in the comments below. Engaging with the material and your peers is a fantastic way to deepen your understanding. To check your understanding right now, head over to our website to take the extra practice quiz. Thanks for watching, and we will see you in the next lesson.